one?
When did TJ answer for all of us?
All right. We're going to do it. I think
That's
we're going to get
probably shouldn't answer for all of us.
Yeah,
thanks, TJ.
Y'all might want
Yeah, but these are opportunities. Listen, every wrong answer is an opportunity to learn more. You know, I would be very disappointed if I learned everything because
Then you can't learn anymore?
yeah. I get, you know the dopamine effect?
Yeah.
I get the dopamine effect when I learn something. And so to know that I would never experience that ever again in my life would really disappoint me.
Learning is your drug.
Love it. I do. It is. It really is. In fact, somebody said yesterday, we were talking about something, and somebody said, learn something new every day. I was like, I try to. Okay. So we're on 15. 15 says that a function f of t gives, did you?
No.
Okay. Yeah, this one we don't even have to write down. We just got to talk about it.
Oh, what?
A function f of t gives the rate of evaporation of water in liters per hour from a pond, where t is measured in hours since 12 noon. Which of the following gives the meaning of the definite integral of f of t from 4 to 10 dt, right? Okay, in the context described. What do we know? In this case, what kind of problem is this probably? Yeah, a net change, a total change, or an accumulation, right? Okay, the question is this. What do 4 and 10 represent?
4 p.m.
Which times? 4 p.m. until 10 p.m.
Oh, yeah.
Because time starts at noon.
So it has to be after.
I
Go ahead.
thought net change you would put like 1 over 10 minus 4.
That would be for the average value of it.
Oh, I had those switched.
Yeah.
Okay.
Yeah. So this is that would be average value. So if if time 0 is 12 noon,
Oh, is it
then
C?
4 is I think it is no wait. No, it's a total. Oh, it could be net change. Yeah, but the thing is, C says the net change in the rate of evaporation. Okay?
I was about to put B when I was in.
Yeah. If we integrate a rate, we get the total change in the value of that thing. Okay? C would probably be correct if they said that f of t was the rate of evaporation of water. The second derivative. You see that? Yeah.
In E, I just thought it was kind of curious. It says the average rate of change and rate of evaporation in liters per hour per hour.
Right.
That's the acceleration.
That would be acceleration.
Okay.
Yep. That's the acceleration of that's the rate of change in the rate of change in evaporation of water. You see that? But when we integrate the rate of change in evaporation of water, okay? Or excuse me, not the rate of change in the evaporation, it's the rate of evaporation of water. When we integrate that, we get the total evaporated water. We drop the word rate, and we just get the evaporation of water. And we replace it with the word total evaporated. Okay, so A says the total volume of water in liters that evaporated from the pond. That sounds right so far, doesn't it?
Yeah.
Total volume of water evaporated in liters during the first 10 hours after 12 noon. What would this have to be for that to be true?
That would be
0 to 10.
0 to 10, not 4 to 10. B, the total volume of water in liters that evaporated from the pond between 4 p.m. and 10 p.m. There you go. Option B. All right.
I had it between that one and D. I had those switched.
50-50, right? But now you know, right? Average. An average is when you have the 1 over 6 in front of it. Okay? All right, number 16 says the first derivative of the function f is given by f prime. It says f prime of x is 3x to the 4th minus 12x to the 3rd. When I see something very clean like this, I start wondering if they're going to have me integrate. But I don't know if that's what's happening here. What are the x-coordinates of the points of inflection? Oh. What do we have to know for the points of inflection?
The second.
Yeah, the zeros of the second derivative. So, second derivative, f double prime of x is
12x cubed.
12x cubed.
Minus 24x.
Hang on.
No, 36x squared.
36x squared, right?
Brandon.
Okay, now, you don't have a calculator, but guess what you can do with this to make it easier? Skip it, exactly. look at this.
You know
There's
that
a,
zero's one.
yeah, you can what?
You know that zero's one because.
You know that 0 is one of them, right? Because they all have x's in them, right? Okay, so we know that 0 is a possibility.
Alright,
Okay,
so that takes
So that's the last three.
Well-
B and A.
hang on a second. Nope. Let me show you why. I'm going to factor this.
Oh.
Oh,
I'm going to factor this. Okay. What can I take out numerically? What can I take out?
12.
A 12, right? What else can I take out?
X.
Okay, x, not just x, but x
Squared.
squared, right? So I can take out a 12x squared. What does that leave me here?
X.
X, and what does that leave me here?
Minus
Minus 3, right? Now, this is x squared, which means it doesn't cross over the x-axis. If I were to make a sign chart of this, there would be a 0 at 0 and a 0 at 3. And then here, it would be, if I put in -1, I would get a negative value times a positive. This would be negative. If I put in 1, I would get a negative value again. And then if I put in 5, I would get a positive value. The second derivative goes from negative to positive. Concave down to concave down. Is that an inflection point?
No.
No.
Nope.
Oh, inflection point is when it changes.
The second derivative must change signs to be an inflection point.
A.
Yeah, so it's A. And that is one of the most misunderstood things. In fact, I have a list. I'm going to print it up and give it to you guys. Hopefully, well, I'll try and get it by tomorrow or Saturday.
Oh, so 0 is a 0.
It's a 0 of the
Doesn't
second
change
derivative, but
sign,
because
so
the
it's
second
not-
derivative doesn't change sign, it is
I'm
not
really confident
an
on
inflection point.
Why is 0 a 0?
What's that?
Why 0 a 0?
Because there's an x in every term. Whenever you have an x in every term in a polynomial, 0 is a 0.
Because it's just gonna multiply.
Because this is going to multiply to 0, this is going to be multiplied to 0, and 0 minus 0 is 0. Okay. All right, 17. Let f be the function given by 1 over x. What is the average value of f? Here we go. This is all you, Jeremy.
Oh, is it?
What is the average value of f on the interval from 4 to 6?
Get it? F.
How do we do an average value? Now, this is not saying average rate of change. If it was saying average rate of change, it would be asking for f of b minus f of a over b minus a. It's saying average value. And average value requires what kind of technique?
So 1 over.
1 over.
minus 4.
1 over 6 minus 4, which is 1 over 2, and then what?
From 4 to 6.
Definite integral from 4 to 6 of what?
1 over x.
Of 1 over x dx.
I just
Oh,
didn't
I
have
forgot
to-
to do the 1 over 6.
That's what I didn't do in this.
Most common mistake in an average value. Most
Did
common
that.
mistake. So
One
now,
over-
what is the antiderivative of 1 over x?
Log.
Natural log,
Very absolute value. But
right? Plug in from 4 to 6. What are we going to plug in first?
Natural log of 6.
Natural log of 6,
Minus natural log of 4.
natural log of 4, and then we ultimately we have to do 1/2 of this, right? Okay?
Oh,
Alright.
I'll probably-
What is okay, you guys, we just talked about this, right?
1 over. The natural log of 6.
6 over 4, right? Natural log of 6 over 4.
That'll be the natural log of 6
Ooh,
over
they
8.
go for that.
Nope, hang on. What's 6 over 4 reduced?
3 over 2.
Natural log of 3 over 2, and we have to do 1/2 of it. Is this one of the options?
Wait. Say that again.
Okay. Because it's the natural log of 6 minus the natural log of 4, it can be algebraically reduced or simplified to the natural log of 6 over 4.
Okay.
Right? 6 over 4 is the same thing as 3 over 2. And it's 1/2.
Oh, so what I
See, I
did
didn't do
was I multiplied by 1/2 first.
Here and here.
So then I got a natural log of 3 over 2, but not the 1/2.
oh.
Right, but you know what would happen when you did that? 1/2 of the natural log of 6 is actually equal to the natural log of the square root of 6.
Well, I did not know that.
Yeah. Yeah. It's better to leave the 1/2 on the outside to handle this first.
I didn't know that logarithm rule.
Now you do.
So I did E 1/2 ln 2 because 6 minus 4 is 2.
I see.
Yeah.
And you know, remember, I may have told you this. You don't have to simplify, but you do have to know how to simplify. Because on multiple choice questions, they'll often simplify the answers. All right, this one's cool. I like this one. Honestly, this is. Remember how I said that there were 3 tough ones? This is one of the hardest ones.
Hey, I guessed 17 right.
Did you? Oh, wait, did we do, oh,
17, that
17?
one
Did we
we
do
just did.
17? We just did 17, right?
Yeah,
Okay.
I guess that one, right?
Alright, awesome.
Just realized it.
All right, 18.
I got this one right.
They even gave you a diagram.
I was getting right over this.
All right.
I was. It took me like forever to figure
Is that
this
the one
out.
you said you like finally figured out?
No, I got that one wrong.
Okay. So,
I was so confident.
it says the points 3, 0, right here, x, 0, right here, x and 1 over, so this is the graph of 1 over x squared, okay? X and 1 over x squared, x and 1 over x squared, and 3 and 1 over x squared. Notice that this is the same, this 1 over x squared, it's the same height here and here. So you didn't plug 3 in. This isn't 1 over 9. It's 1 over x, whatever x is, squared, right? It says, and x is a value greater than or equal to 3, as shown in the figure above. For what value of x does the rectangle have a maximum area?
It can't be 3
That's true.
because
Yeah.
it would make it 0.
Yeah, we already know that if this is 4, that it's going to have area. So we know it's not going to be 3.
4
All right.
will give you 1/16 square.
What's that?
Oh, I just plugged it.
Yeah, you could just plug in all the answers.
That's what I
See
did.
which
Yeah.
one's the closest.
Yeah, and see which one's, yeah.
The largest.
But let me show you the correct way of doing this if you did it calculusly. Okay? All right. It's an optimization problem because it says maximum area. And since we're maximizing area of what? We're maximizing the area of a rectangle. So I need the formula for the area of a rectangle, which is base times height. Well, the base of this rectangle area is given by x minus 3. That's the base, right? The distance from here to here is larger number minus smaller number. So the base is x minus 3, and the height is going to be, the height of the rectangle is 1 over x squared, right? So our area formula is actually x minus 3 over x squared. Yes, sir?
Since 1 over x squared, it's an asymptote approaching 0, right?
Yes.
The larger the number got, the closer your answer would get to 0, correct?
Yes, that's correct.
So it had to be 4.
Well, then why wouldn't it be 3?
Well, 3 is 0.
It would be 0.
That's true, but
That's
here's the
what I
thing. Here's the interesting thing about squares is if going the other way, it does the exact same thing that it does going this way. What if 4 is right here? Well, then it's a thin, tall rectangle. Do you see what I mean?
Mm-hmm.
Isn't it approaching 0 on both sides?
Yeah.
If it's approaching 0 on both sides, then there must be a maximum in the middle. So it could be 4, but couldn't it also be 6? Or maybe 9 is the maximum in the middle. It just has to be something between 3 and infinity. See what I mean? How do we do an optimization problem? If this is the area, how would I optimize this problem? What's step 1 in an optimization problem?
Find the area equation.
Well, I have the area equation. The area is now, yeah. And then what do? Once I have the function, not integrate,
Find the sides.
optimization. Step 1, critical values.
Oh.
We need the critical values.
Okay.
So we need the maximum, or not maximum, we need the zeros of the,
Or
derivative.
Derivative.
We need
Yeah.
we need area prime here.
Oh.
We need a prime. How do we do the derivative of this? Quotient rule. Derivative of the top, 1 times the bottom, x squared, minus the top, x minus 3, times the derivative of the bottom, 2x over the bottom squared, x to the 4th. So if we clean this up a little bit, it becomes x squared. If I distribute this 2x, it becomes 2x squared minus 6x, and we're subtracting that. So it becomes minus 2x squared plus 6x, all over x to the 4th. This cleans up. X squared minus 2x squared is negative x squared plus 6x over x to the 4th
Wait, where did negative 2x go?
Negative 2, it was negative 2x squared.
Oh, equals negative.
Because 2x times x is 2x squared,
Yeah.
and x squared minus 2x squared is negative x squared.
Oh, negative 1.
Right.
Okay.
And now watch what I'm going to do here. I'm going to cancel an x here, I'm going to cancel an x here, and I'm going to cancel one of the x's here, right? We know that all the values are positive, right? What will make this derivative equal 0?
0.
No, actually not 0. What I mean is,
6.
right,
the
what
top
do
half
I
is
have to
0.
do? I have to make, in order to make any fraction equal 0, I have to
top
make
has
the
to be 0.
numerator.
Okay.
So all I have to do is do negative x plus 6 equals 0. And there's only one value that's going to do that. 6. C.
Oh, that's what it was.
Now, if you want to be sure, that might be a minimum. But you know how I know it's not a minimum?
Because it's always below.
Well, because 3 is smaller than 6. If I plug 3 in, I get 0. Right? So it must be a maximum. Logically. It's multiple choice, you don't have to explain. But you know what I did? I went ahead and plugged 4, 6, and 9 in. And I got like 1 over
116.
13.5 for one. I got 1 over 12 for the other, and 1 over, I think, 14 for one of them. And this is the largest. That's when I plugged 6 in.
So the answer is 6. But
Yep.
where did the x cubed come from?
I canceled an x in here, here, and here. You didn't have to do it all this way. I'm just showing you if this happened to be like on free response. Yes, sir.
What would have been the, like, what would you say was the best way to answer this? Do that or just plug it in?
Depends on how much time you have.
Mm,
Like, this could be the sort of question where you come back to it. Let's say you're done with the whole multiple choice, all 28 questions except for this one, and you have 5 minutes. Well, maybe you try the derivative. But if you have 30 seconds left, plug all the numbers in and pick the largest one. Yeah. Okay, 19. What are all the values of x for which the definite integral from x to 2 of t cubed is equal to 0? Now, just so you know, t cubed looks like this. Okay? What do we know one answer is for sure?
0?
No, not 0.
2.
2, right? Definite integral from x to 2 of t cubed dt. Won't this equal 0 if I put a 2 here?
Uh-huh.
So 2 has to be one of the answers. So automatically, it's either C, D, or E. I don't know. We had to come down to a low level there. Sometimes we're thinking at the hard level that we forget to go down to the easy level. And they put this easy question right after this hard question. Right?
Yeah, I mean, that makes sense.
Do we remember that if we integrate from the same number to the same number, the answer is 0?
There's no
There's no
area
space.
of.
Correct. There's no area here, right? So the area is 0. Here's the thing. Here's why it's not C. It's also not E. You know how I know it's not E?
Because 0.
Because we'll get an area. If we integrate from 0 to 2, we're going to have an area.
Oh, I
See?
know why negative 2 did. Because if it'll cancel. The
That's
negative
correct.
part on the left.
That's right. This is going to be a negative value, and this is going to be a positive value, and those are going to cancel each other out.
And it equals 0.
Yep.
Nice.
So it's E.
If we didn't know that that's how the graph looked, would because
Oh, you can just, if you have time, just do it, right? Antiderivative of t to the third is 1/4 t to the 4, right? Okay. You're basically looking for a number. Okay, you know you're going up to 2. How many numbers can you plug in here and get the same number as if you plugged this in? One other, or no, well, yeah. If I plug a 2 in, I get 16, 1/4. This is 4 when I plug a 2 in.
Negative 2.
If I plug in 2 or negative 2 in here, I get 4, correct? Which is how I know that the answer is 2 or negative 2. What did I do wrong?
16, right?
Well, 16
16
divided by 4.
Okay, so it's always like that. Like, no matter if it's the negative number or the positive number.
Well, understand that if this said 2t squared, Now the only answer would be 2. Because it would now look like this, and integrating from -2 would now give us positive value. The only reason it worked was because it was a t to the 3rd power. Did I don't know if that answered your question.
It did, but I'm just not happy with it.
So it's
It's D. Yep.
I was looking for a yeah.
Do you see how-
It's always like that.
Do you see how knowing functions plays an important role? And the state of Georgia has failed you in making sure that you know functions because they invented this crazy accelerated program where you don't learn it better, you just learn it faster. That's correct. And learning something faster means learning it less every time.
Just like how they're trying to build the bridge on the I-85 faster. Bad idea.
I mean, they still got to go through like civil engineering inspection.
Oh, sure, yeah. But now I want you to consider the guy who doesn't get his bonus if the civil engineer doesn't do his job faster, right? And the dude who's not going to get his bonus is best friends with the civil engineer's boss. And the boss says, look, just get it done. Whatever has to be done. Just get it done. It's got to be done by now.
Corruption.
Has to happen.
That's how
That's
it
exactly
was.
my point.
They
Yeah.
already, I think they already fixed the part of I-20 that blew up.
Yeah.
I am built
That's a really stupid
for
way to
accuracy,
explain that.
not speed. That's correct. Yep. Okay, 20, which is why we might not get all through all these questions. Let h be the function defined by h of x is equal to this thing. H of x equals definite integral pi over 4 to x sine squared of t dt. I'm
Okay.
feeling the fundamental theorem of calculus here.
Okay, so I knew that it had to be either C, D, or E
Okay.
because x equals pi over 4. So
Yep.
it had to be one stuff.
Nice.
Yes. Yep. Because with pi over 4, you know you're going to have y equals 0, right? All right, hang on. Let's take a step back. Which of the following is an equation for the line tangent of the graph of h at the point where x equals pi over 4? Well, to get an equation of a line, I need an x, I need a y, which will be h of x, and I need h prime of x. I need 3 things. I need an x, a y, and a slope. I need an x, an f of x, and an f prime of x. That's what I need. Since x is at pi over 4, h is going to be h of pi over 4, and h prime is going to be h prime of pi over 4. These are the 3 numbers I need. And then I'm going to set them up as y minus this number equals this times x minus this number.
I almost had it, I just didn't know the slope.
You didn't know? Okay. All right. So what's h of pi over 4?
That's a
If I put pi over 4 in for x, what is that definite integral going to be?
0.
It's going to be 0. Right?
Yes.
All right. What is the derivative of h of x?
1 times sine.
1 times
I mean, sine squared x.
sine squared of x. That's the fundamental theorem of calculus, right? Okay. And now if I put a pi over 4 in here, what's sine of pi over 4?
Square root of 2 over 2.
Square root of 2 over 2. And if I'm going to square that, it's square root of 2 over 2 times square root of 2 over 2.
That's a 2 over 4.
1 half. So whichever one is y minus 0 equals 1 half of x minus pi over 4 is the correct answer. And they probably simplified it. Yeah, they took out the 0.
Man.
You see that? Do you see what I did there, Brandon? So you knew it was C, D, or E?
Yeah.
You just had to get the slope right. I know I did that real fast.
So to find the slope, you just do the derivative.
The derivative of this thing, and the derivative of one of these things, which is the last thing we did in my class,
Just the thing.
is derivative of this times this with this plugged in for t.
Okay. So it's just sine squared of x.
Yep. And then plug pi over 4 in. All right.
Big deal.
21. Table above gives selected values for a twice differentiable function f. Which of the following must be true? Twice differentiable means that the function has a derivative and its derivative also has a derivative. Okay. Which of the following must be true? All right, I'm going to tell you that the answer is B, and I'm going to explain how I know that. It's because I didn't teach you guys the mean value theorem. A couple of y'all were in here when I taught the mean value theorem, but the mean value theorem is something I left out of the curriculum on purpose. All right, f has no critical points on the interval from -1 to 5.
No.
How do you know that? Isn't it possible?
Mhm.
In fact,
Yep.
in order to go from -30 down to -2 and then up to 10,
Yeah,
wouldn't it have to turn around?
Yep.
There you go. So it definitely has a place where the derivative is equal to 0. Let's jump to C. F prime is equal to 0 for all values of x on the interval from -1 to 5. So you're telling me that the derivative, the slope of the whole function is positive. Well, we went from, oh wait, hang on, I said -30 to -2. Oh, no, that's,
yeah.
I messed up. Oh, okay, hang on.
It goes straight up.
It does go straight up, I'm sorry. Okay, here's the question. Is it possible, is there any information in here that says that it doesn't turn around somewhere?
No.
And that's the issue here, is it doesn't say strictly increasing. What I'm saying is this, you have to ask yourself, is it possible that somewhere between two of these numbers that it did this?
Yep.
See what I mean?
Yeah.
And if it did, this is saying which of the following must be true, not could be true. Must be true. So is it possible that somewhere between -1 and 5 that it turns around somewhere?
Yes.
Yes, so then it can't be A. C. Is it possible that somewhere between -1 and 5 that it turns around and slopes down and then slopes up? Okay, so it can't be C. D. The second derivative is less than 0, meaning that this from -1 to 5, the whole thing is concave down. Wasn't it possible that it's concave up somewhere and they just didn't give us enough information to know that? So then it can't be D. The graph of F has no points of inflection. Well, if we say that D is possibly wrong, then wouldn't E then possibly be wrong? If there's a place where the graph is concave up, then wouldn't there be a point of inflection? But let me explain why B is absolutely true.
Because it's gonna hit 8 somewhere.
Yes, because if we do f of 5 minus f of -1 over 5 minus -1, okay, we get 18 minus -30 over 6. We get 48 over 6. We get 8. This is the average rate of change. You are the only one, as far as I know, that hasn't seen this yet.
Oh, that doesn't sound good.
Well, because I think these guys were here at some point for the mean. Did you learn the mean value theorem? Okay. All right, look up the mean value theorem.
Okay.
This is the average rate of change, the slope of the secant line between the two endpoints. If the slope between the two endpoints, is 8, somewhere on the middle, there's a place where the actual slope is equal to that. That's what the mean value theorem says. So this is basically just asking you about the mean value theorem. See, f prime of x equals 8 means that the instantaneous rate of change, the slope on the curve is 8. There will always be a point where there's on the curve between two x values where the slope is equal to the average rate of change between the 2 points. If the function is differentiable on the whole. And it told us from the beginning that it's twice differentiable. Right? All right, that's why it's B. All right, let's go to 22. Particle moves along the x-axis so that at time t greater than or equal to 0, the acceleration of the particle, oh, this one was a fun one.
I guessed on this one.
Yeah. This is actually,
I got it right, but I don't know.
this is actually pretty fun. Okay.
I might-
The position of the particle, okay, at time 0 is 10. The position of the particle at time 0 is 10, and the position of the particle at time 1 is 20. What is the velocity of the particle at time 0? Okay.
Oh, wait.
The velocity is the antiderivative.
Yes, the velocity is the antiderivative of acceleration, right? I'm going to make it t to the 1/2 power. Is that okay?
Yeah.
Okay, so antiderivative of this, add 1 and multiply by the reciprocal. So this is 3 over 2, right? It'll be t to the 3 over 2 power, and we have to multiply this by 2 over 3. Is that okay?
So,
So it's, yeah, so it's 10. So the velocity is 10t to the 3 over 2 power plus c.
That's as far as I got.
Okay, ready? If that's the velocity, then the position
it's the antiderivative.
is the antiderivative of 10t to the 3 over 2 plus c dt. Now, can we agree that c is a constant?
Yes, I do.
Okay, so no, we don't want to get rid of it. We want to leave it in. It could be a value. We want to know what it is. All right, so watch this.
Kill.
How do we do the antiderivative here? Add 1, so that's 5 over 2, and then multiply by 2 over 5.
That's a 4.
Right? So yeah, 2/5 of 10 is 4, right? So this is going to be 4t to the 5 over 2 power plus ct.
Plus d.
K. D would be fine, but I picked K.
F.
All right, some constant. Now, we know that at time 0, the position is 10. So if I put a 0 here, and I put a 0 here,
What would get us?
what would give us 10?
For K.
K would have to be,
6.
no, 10. Because look, this is
Oh,
0,
right, okay, yeah.
and this is 0.
Oh,
0
yeah.
plus 0 plus
Jeez,
10. So K must be 10.
Ooh, I
Okay?
See, I see.
And if K is 10, and the position at time 1 is 20, well, 1 to the 5 over 2, this is the same thing as the square root of t to the 5th power. 1 to the 5th power is 1, square root of 1 is 1. So this is 4 plus c times 1 is c plus 10 equals 20.
Then you solve for C.
C equals 6. Back up here, C is 6. Velocity times 0. Put a 0 in here. And what's the velocity at time 0?
6.
There we go.
I don't know.
I'm sorry. But that's how you do it. I mean, that's one way to do it. I'm sure there might be other ways.
What happened at
So-
the very end? Was that time 1?
Yeah.
Time
Yeah,
1.
time 1 here. 1 and 1. And we would equal 20.
So
Well, why does it have to be
I got lost with
plus
that
two?
CFT and the K that you had there. Where did that?
Okay.
Yeah.
Would you agree that this is a constant, like 5 or 19 or something?
Yeah.
Okay? So if I do the antiderivative of this, it would be 19t, right? But instead it's ct. And then I put k in because I need another plus c, but I don't want to use the letter c.
Yeah.
Yeah.
Then I put 0 in for t, because at time 0 the position is 10.
Gosh.
So I got to put a 0 here and a 0 here and set it equal to 10.
That's
Wouldn't that make k equal 10? So then now I have, this is really a 10. And now, when x is, or when t is 1, the answer is 20. So if I put a 1 here, I get 4. If I put a 1 here, I get c, and then I have plus 10, and the whole thing equals 20, making c equals 6. That's a tough one.
Very tough.
No.
23? Yeah, I think this was one of the top 3 tough. Which of the following is the solution to the differential equation 2xy over x squared plus 1 with whose graph contains the point 0, 1? Okay. All right, let's see here.
I know this involved the chain. I mean the U substitution, right?
Yes, it does. Yeah. I mean, I actually just straight up solved it as a differential equation. So dy dx is equal to 2x
That's what I
over
wrote down.
x plus 1 times y. Look what I did there. You see what I did there? I took the y out of the numerator.
Mhm.
So now I'm going to
Wait, why is
multiply.
it x over 1, not x squared?
Oh, thank you. It's x squared plus
Oh.
1. Okay.
So
Now, I'm going to multiply by 1 over y. I took it out of there so that it's easier to understand why I'm multiplying by 1 over
I
y.
thought that was your multiplier.
Yeah.
No.
1 over y, that's going to cancel over here, multiply by dx on both sides, right?
Yeah.
And now I get 1 over y dy equals 2x over x squared plus 1 dx.
Okay, right there.
Antiderivative here,
Oh.
okay? this side is going to become the natural log of the absolute value of y, right?
Yeah, I
Over
got that.
here, we're going to need u substitution,
That's fine.
right? Now, so u is going to equal x squared plus 1, du is going to equal 2x dx, and now if we do 1 over 2x, du equals dx. So now this is going to become the antiderivative of 2x over u times 1 over 2x du. And what's going to happen here? That cancels and that cancels. And we now have the antiderivative of 1 over u du. What's the antiderivative of that? We just did something like it right there, didn't we?
Natural log of u.
Natural log absolute value of u. But now we replace it's natural log absolute value of x squared plus 1 plus c.
Wait, what? Oh, never mind.
You okay?
Yeah.
So-
Initial condition.
Wait, so what? Are you done?
Well, now we have initial condition 0, 1. So we put a 0 in here for x and a 1 in here. What is the natural log of 1?
One.
E to what power equals 1?
Zero.
E to the 0 power, because e to the first power equals e. Right? So, natural log of 1 is 0. Well, this 0 plus 1 is going to give us the natural log of 1 again.
0.
0 plus c. What does c equal to?
0.
C equals 0. Well, if c equals
You
0,
don't need C.
then we don't even need c. We just have the natural log absolute value of y equals natural log absolute value of x squared plus 1.
Then you do big E, right?
Big E cancels the ln. And we have y equals x squared plus 1, which is b.
So yeah, I started off doing it right, and then I got confused when you had to plug everything back in. Let me plug you back in, and then I just got lost.
Sorry. It is differential equations. I told you guys that the ones that I taught you initially were tame, right? At least I think I told you that. That they love the natural log. On the AP exam for differential equations, they love the natural log. They just love it.
Why did you
Hmm?
go over there and do that?
This?
Yep.
Okay, because they told us that the initial condition, that the function itself passes through the point 0, 1.
Yeah.
So I had to put 0 in for x and 1 in for y.
What did you learn from that?
What's that?
What did you learn from that?
Well, the natural log of 1 is 0, so this now equals 0. Again, the natural log of 1 is 0 plus c. I solved for c. I learned that c is equal to 0, which made my original antiderivative much easier because I get to get rid of c now.
Okay, hold on.
Sorry,
That's okay.
I know that one's.
See, yeah.
We're getting there. You guys hanging in there?
I think this is one I need to do like over and over again at home.
That's a good idea, actually. That is a very good idea.
Yep.
Start from scratch, do it again. Start from scratch, do it again. All right, 20. Oh, I'm wondering if we should come back to 24.
Oh, it's like one of the ones I got.
It is?
I got
Okay.
that one right.
That's related rates.
Oh, I suck at this.
Did I guess?
I completely.
I think I guessed.
Okay.
Like, there's
Oh,
no-
All right,
yeah,
let's
that
do
was
it
one of
then.
the things
Yeah,
that-
it's one of those things
Let's-
where at the very end I just filled it.
All right, let's do it then. Okay.
Yeah, this is what I was asking
Even when
you
it was
about.
the related rates test and we
Before
were
they-
doing it.
See, I'm
was
wondering
like-
if I should do a separate video just on this question.
Yeah.
Can I-
What?
Not an hour long. I mean,
Oh,
but
okay.
you know, because I want to get through these other ones. I want to make sure that you guys can see what's going on here.
This is the type of question that I was asking about before we took it, where I said the
Yes,
that
I
wasn't
know.
Here
Yep.
for.
And I said that we would need to
Yeah.
do it separate.
Yeah.
Yeah. Okay.
What's the answer to 24?
I believe it is C. Yeah, it's C.
Oh, I put D.
I put D too.
Let's look at 25 for a minute. 25. Sorry.
Do the pies cancel each other out?
Yeah. Yeah.
Dang it.
All right. We have the limit as h approaches 0 of e
See, yeah.
to the negative 1
I
minus
guessed
h
between C and D
minus
because
e to the negative
we're the
1
same answer,
over
So I
h.
knew what one of them had to be right.
Okay. This is the limit definition of the derivative. It's worth looking up. The limit definition of the derivative. when they give you one of these problems, what they really expect you to do really is try and figure out what function they have plugged into the limit definition of the derivative, and then just take the derivative of that function. Okay? Now, the general version of the limit definition of the derivative looks like this. F of x plus h minus f of x over h. Now, if h approaches 0, this is 0. This is 0, and x plus 0 is x. And f of x minus f of x is 0, so we would have 0 over 0. The derivative. 0 over 0, right? Okay, it's f of b minus f of a over b minus a. Okay, delta x here. All right, so watch. This needs to not be minus h. It needs to be plus h. How can we fix that? Look at it. Think algebra. How can we make that plus h instead?
Absolute value.
Well, that would be nice, but we got to do something algebraic here.
H minus 1. Or H.
These are both negative.
Switch it.
When we do algebra, first of all, if it's not an equation, all we can do is change what it looks like. We can't change it into something else. So, -1 minus h.
So you want plus h?
We need it to be plus h.
H minus -1?
H. Well, then the h isn't negative anymore.
Can we multiply both of them by negative?
That would be nice, except again, it's not an equation, so we don't have
Can you
something else to
factor out a
multiply.
-1?
Factor out a -1.
Oh.
So if we factor out a -1, this becomes -1 times 1 plus h. And then change the number, well, not change, but this number, whatever number is now here with the plus h, that number is x. So what does x equal here?
1.
X equals 1. So then, replace the 1 with an x. Okay? And now it would be negative x plus h, right? And what is this inside of? E. Last thing. The x plus h is supposed to be just an x. So what would this become if this was just an x? That's the function that you're doing the derivative of here. Look up the limit definition of the derivative. The limit definition of the derivative. We spent a little bit of time on it back in September.
What was the answer to that?
Well, here now, what's the derivative? So this is basically just asking you to find the derivative of this and then plug in 1.
So e to the -1.
Close. It's actually the derivative of this is negative e to the negative x. Because this is not just x, it's negative x. So you have to do the derivative of the inside, -1, times the derivative of the outside, inside unchanged. So it's now if I plug 1 in, what do I get? Negative e to the -1. E to the -1 is 1 over e.
So -1 over e.
-1 over e. B.
Wait, e to negative e to the negative
So
1.
just guess that one.
-1.
Yes. Or,
And then next.
yeah. Now remember, you can get a 3 with about 50% correct. So if you thought you could get half of the ones we've done so far correct, probably.
I got
Yeah,
almost
I
half
don't
right.
believe that.
Yeah.
What do you need to get a 4?
Oh.
Probably closer to
All of them.
somewhere between maybe around 57% or so.
Hey, what does Kennesaw take?
All right,
3.
let's look at
Lucky.
26. I'm sorry, guys.
Short colours.
What do they
What do they-
take?
4.
Just
I'm looking for a college that takes a 1.
Homeschool.
I took the AP exam. Good enough.
Yeah.
Okay. 26. Let f be the function given by f of x equals x cubed
I left this blank.
Yeah, paid
no,
like
really?
$3, but
Plus
I got
5x.
one and paid 15.
For what value of x on the interval from 1 to 3 does the instantaneous rate of change of f equal the average rate of change of f on that interval? Okay, let's find the average rate of change on the interval.
F of 3
F of 3
minus
minus
of 1
f of 1
over 2.
over 2 over 3 minus 1, right? And what's f of 3? Put a 3 here.
They're 42.
42, yeah, because it's 27 plus 15 minus. Let's put a 1 in.
Wait.
6. Sorry. If I put a 3 in, 3 to the third power, 27 plus 15 times or 5 times 3 is 15, and then 1 plus 5 is 6 over 2. 42 minus 16 or minus 6 is 36. 36 over 2 is 18. So we want to know where f prime
That's
equals
as far as I got.
18. Well, how do I find where f prime equals 18?
Find the derivative.
Find the derivative. All right. And what is f prime equal to?
3x squared.
3x
plus
squared plus 5 equals 18.
5. Solve for x.
Solve for x, right? Plus 5. Yeah, so I can subtract 18 here, right? And I get 3x squared. Actually, no, it's better if I subtract 5. Sorry. If I subtract 5 from both sides, it's better. I get 3x squared equals 13. Divide by 3. X squared equals 13 over 3. Square root.
And that's the answer.
X equals plus or minus the square root of 13 over 3. But it says that this number is between 1 and 3. It's got to be positive. So B.
This is so simple, but I just.
Yeah.
It's okay, listen. I don't care what you get on the AP exam. I know you do.
Yeah, I know. Georgia cares.
Okay? Yeah, but tell me the absolute, see, this is how economists think. What is the absolute worst thing that is going to happen to you if you don't get the goal that you want on this test?
$90.
Wait, hang on, say it again.
My parents lost $90.
Is that big of a, have they lost $90 before?
Yeah.
They
No,
survived?
I'm saying that's not.
Tell them that if they are in a $90 bind in the next 5 years, call me, I'll give you $90. What's the worst thing that's going to happen to you?
My bride.
Okay,
Oh, see, my pride's already in.
I $4. I mean, that's not.
what could happen? See, we
Yeah,
already discussed that yesterday,
I might
right?
go ahead and lose
It's
$15
about all the good
for
things
call
that
it
could
a day.
happen from you taking
But
calculus
if
in
you
college.
think about it like that,
Yeah.
what could happen if I didn't have to take it and I took something else instead?
Oh,
And
You
while I
could
was
be-
taking
That's
that
true.
something
You
else-
could be
Yes.
on
Yes.
on the road to go to that class and get in a car accident.
that's
All
true.
your life.
This is
It's
going
all
straight
about-
like pessimist.
He was talking
Well,
more
no.
like meeting your future wife or something.
I
That
would-
works too, I guess.
I was talking about
You
taking
could
a different
die.
class.
I didn't
Well,
say
that's
you
true.
die.
But what I'm
Maybe
saying,
you
hang
beat
on a
your
second.
wife for that car accident.
What happens if you don't take calculus
Maybe
at
the
all
other
in college?
other person.
Like, hey, I know
is
you
your
did me,
wife.
but you're kind of cute.
What I'm saying though is this:
I
is
think
you
you
guys
would
are
beat me
all already ahead of me because I didn't even start college till I was 25, and I got a D on my first test in calculus
It'll
when I was
save
in
us
college.
couple
Okay.
$1,000.
Sure, yes, I agree with all of that. But let me
So
tell you
really,
something.
not $90.
What I'm saying though is this: is that the marginal impact. Here's what I'm gonna predict.
Zillmillers.
Not for everybody, but for most people, the marginal impact. So now we're thinking derivatives here, okay? A marginal is a derivative. The incremental rate of change, the incremental impact, okay, of you not getting what you want on the AP exam is probably insignificant. It's
And
probably really, really
Talk
small.
about the positive. Like,
Yeah.
I thought
Well-
I was making a 5 or something.
Yeah, well, no, that's the thing, though, is,
over here talking
hang on, but, right, I'm not encouraging you to not do your best. I want you to do your best, but what I'm saying is this is, you actually will do better on the exam if you walk in calm, knowing that the outcome of that test is not catastrophic either way. If you just walk in calm and do what you can do, right?
Yeah.
Just walk in calm and do your best. That's all you can do.
I think the day of the exam I'll be chilling.
Because you're gonna have just had awesome eggs and pancakes
Oh, that's true.
from Mr. Ryan.
Well, I'm gonna be
Yeah.
stuck
Okay.
going in that.
Oh yeah.
Okay. Given that I have to start the video over again in just a few minutes, I'm gonna skip for now. I'm gonna skip number 27. Okay. All right. Let's look at 28.
Leave the part about the car accident.
Yeah.
F of x equals x cubed plus x squared plus x.
27 and 28 right.
All right. It says
Oh, I guess
g of x is equal to f inverse. Excuse me. F inverse of x.
The answer to
All right.
28E.
What you guys know, it's C.
It's because I guessed all C's on.
Oh, yeah.
I didn't know, so.
All
I
right.
think I was on the right
Here's what you guys. I don't know if I taught you guys this, but I need you to understand something. Watch this. I'm going to draw a curve on here, okay? And let's say that curve does this, okay? I'm now going to draw the inverse of that curve, and the inverse of a curve is a reflection across the line y equals x. So this is the inverse, okay? There's a curve, and here's its inverse. Did you know that if this curve passes through the point 2, 5,
It's gonna pass through 5,
5,
2.
2.
this curve passes through the point 5, 2. Okay? That's how inverses work. Okay? But did you also know that if the slope of this at that point,
2.
if the slope, okay, is
That'll be 1/2.
2, then this slope will be 1/2. Yep. That the slope of the inverse function is always the reciprocal of the slope at the inverse point.
We're getting
Okay?
somewhere.
Okay.
Does that make sense? Okay, but now you know, right? So, this question says that g of x is the inverse of f of x. And it says that g of 3 is equal to 1. Well, if g of 3 is equal to 1, then f of 1 is equal to 3. Right.
And that's where I stopped.
And we want to know what g prime of 3 is. That's what it's asking. What's g prime of 3? Well, what will help us find out what g prime of 3
The
is?
slope of that.
F prime of
1.
1.
Ooh.
Oh.
So find the derivative of f of x.
Which is?
3x squared plus 2x plus
And plug in
1.
and get.
6.
And so the slope at g prime is at 3, 1, 6.
Wow.
Man.
Just some knowledge.
Plug,
Isn't that cool?
Go along with.
plug in 1 to that.
Into, find the derivative. Find the slope
Yeah.
of f at 1, and then do the reciprocal to get the slope of g at 3.
Okay, so when you plug 1 in, it's 6.
Yeah, because 3, 1 squared is 3, 2, and then 1, so 3 plus 2 plus 1 is 6. That was easy, right?
Yeah, I totally didn't guess that.
Do you want to now go back to 24 and 27? And I'll start a new video? Alright. Let's start a new video here.
We have you Monday and Tuesday, right?
Yep.
How long
For 3 hours?
did you finish those
No, not this time. It'll be the regular hour and a half.